So, here we have a more complicated forces question. We want to find the distance that this box travels after it leaves the ramp. So, we know that the ramp is 15 meters high. We know that the angle the ramp is at is 30 degrees. We know that the coefficient of kinetic friction of the part after the ramp is 0.1. The coefficient of kinetic friction of the ramp is 0.5. And the mass of the box is 3 kilograms. So our first step is to find the acceleration of the box down the ramp. Since it is, in fact, accelerating. So there are no forces being pushed onto the box, so there's no force going this way. But it is accelerating that way. So we have the weight of the box, and we have our normal force, which is always perpendicular to the surface the object is on. And then we have our kinetic friction, which is parallel to the surface. So that means that the kinetic friction and the normal force always form a 90-degree angle. So our first step here is to calculate our sum of y forces. So first we actually need to break down our weight into two component vectors. Here is the y value, and here is the x. So our ramp is like that. So using angle, sum of angles, differences of angles, we find that this angle right here is 30 degrees, which is the same as the ramp. So we'll call this the first component. Actually, I'll explain that later. So our first step is to do our sum of y forces because there is no vertical acceleration. So the sum of the y forces is equal to, we'll say the normal force is positive and the weight is negative, the normal force minus, so what is this force? Well, it's the adjacent to this angle, so it's really weight times cosine angle, and our angle is 30. So it's weight cosine 30 degrees, which is the square root of 3 over 2. And so all we really need to do now is just say, since there is no vertical acceleration, our sum of y forces is 0, so our normal force is equal to the mass times the acceleration due to gravity, which is the weight, cosine 30 degrees. Or is equal to the square root of 3 over 2 times mg. So now all we need to do is do our x forces. So we have our sum of our x forces is equal to, so first we have the force in which there is acceleration, which is the second weight component, and that is the opposite to the angle, so that's going to be weight times sine 30. Weight sine 30 degrees minus the kinetic friction. Now all we need to do is just replace some of the variables. So this is really equal to mg 1/2, because sine of 30 degrees is 1/2, minus mu k F times the normal force, which is the definition of kinetic friction. So now we can just plug in our normal force, which is just radical 3 over 2 mg, and so now the sum of our x forces is equal to 1/2 mg minus mu k mg times the square root of 3 over 2. Finally, we just say that the sum of our x-forces is the mass times the acceleration, because F equals ma, and the mass actually cancels in this case. And we're just left with the acceleration is equal to 1/2 the acceleration due to gravity times 1 minus the coefficient of kinetic friction of the ramp times the square root of 3, which is about 1.7. So that means that our acceleration is about 1/2 times 10 meters per second squared times 1 minus 0.5 times the square root of 3, which is just the square root of 3 over 2, which is about 0.83, So that's acceleration is equal to 5 meters per second squared times 1 minus 0.83, which is 0.17. So it's actually 1 minus square root of 3 over 2 is 0.13, and so that means that our acceleration is actually 0.65 meters per second squared. So we know that our acceleration now, so now all we have to do is just calculate the acceleration, the speed, the initial speed at the bottom of the ramp. So our box starts at rest, and its acceleration is 0.65 meters per second squared. It's going down like that. So since it's like that, all we need to do is just calculate the speed here. So to find the initial velocity of the flat surface, which is really the final velocity of the ramp, of the box on the ramp, we use Vf squared minus V initial squared, which is really 0, and Vf squared is really our V initial here, is equal to 2 times the acceleration times delta x. So we can actually find our delta x by doing 15 by using our tangent, because tan of 30 would be equal to 15 over this value. So 15 over the tangent of 30 degrees is how we get our value, which is about 26. So that means that delta x is about 26 meters. So now all we need to do is just calculate everything to get our final velocity. So that means that our final velocity is equal to the square root of 2 times the acceleration, 0.65, times the distance that it traveled, which is not 26 meters because I'm stupid. We need to find this distance, the hypotenuse, which is really 15 over sine of 30, which is 1/2. So it's 30 meters. Because I'm stupid, I forgot that this is our x here. This is the distance that the box is traveling on, times 30 meters. Forgot the units. Meters squared over seconds squared times 30 meters, which is about 6.24 meters per second. So we found the velocity at the bottom of the ramp, which is our new initial velocity. So now we need to find the velocity here, at this distance. So first we need to find the acceleration of the box, which is going to be negative because it's stopping. We have our box for our free body diagram. We have our frictional force. There's no force going the other way because there's nothing being pushed against it. It's not being pulled in that direction. The acceleration is this way. So positive acceleration is in the direction of our kinetic friction. There's also weight and our normal force. And so now we're just going to do our sum of y forces is equal to the normal force, we'll say, is positive, minus the weight, we'll say, is negative. So our weight is mg, and there's no vertical acceleration, so this is equal to 0. So the normal force is equal to the mass times the acceleration due to gravity. With this, we can do our sum of x forces, and we find that the sum of x forces is equal to just the coefficient, well, the direction of positive acceleration, but it's the negative direction because it's moving in the opposite direction. So this is positive acceleration, but negative velocity, which means that it's slowing down, is equal to negative kinetic friction. Because just because it has positive acceleration in this direction doesn't mean that the force is in fact positive, because it's the negative velocity. It's in the direction opposite of the direction of the movement of the box. So now we're just going to say the sum of our x forces is equal to negative, replace this with mu k mg, which is just equal to negative mu k, negative mu k times the normal force, which is equal to negative mu k times mass times acceleration due to gravity. Finally, we are going to say that this is equal to mass times acceleration, F equals ma, Newton's first law. And now we're just going to cancel out the mass, and we're left with the acceleration is equal to negative mu k times the acceleration due to gravity. And our mu k is 0.1, our acceleration due to gravity is 10 meters per second squared, so our acceleration is equal to negative 1 meter per second squared. With this, we can now find how far the box will travel across the flat surface by using, since we don't know time, we have to use the fifth kinematic again. The final velocity squared minus the initial velocity squared is equal to 2a delta x. Our initial velocity squared is 39 meters squared per second squared. We don't know, so our final velocity is 0 because it stops. We want to find how far it takes for it to stop, how far the box will travel until it stops. So that's negative 39 meters squared per second squared is equal to 2 times the acceleration, negative 1 meter per second squared, times the distance, which we're trying to find. Now we divide everything by negative 2, and we get 19 and a half meters is equal to the distance it travels. So it will take, after all that, we have found that the box will travel 19 and a half meters after it leaves the ramp. And in total, the box will have traveled 30 plus 19 and a half meters, which is 49 and a half meters. The box will have traveled 49 and a half meters before it comes to a stop.